Okay, what we are doing right now is Unit 5, Activity 2. This is Content 3. And basically, all we're doing here is what we've already done. We're looking at the original person who noted that diffraction could be used to find the wavelength of light. And basically, it's one wave of light coming through, going through two diffraction slits. And by looking at the constructive or destructive interference, we can measure what the wavelength of light is. And all we're going to do is look at a different formula that can be used, and you guys are going to play with the simulation to try and solidify this. So this is called Thomas Young's double slit experiment. And what you have to do is you first have to get this formula down, which says lambda. I tried to put the symbol for lambda in, equals d times delta x over L. Lambda is the wavelength that we're trying to get. D is the distance between the slits. So there's two slits that the waves diffract through. Delta x is the distance between the bright fringes. And we'll show you what we mean by the bright fringes and how to measure that. And then L is the distance from the slits to the screen. There are some check your understanding questions at the end, and they use the term dark fringes. We're using light fringes. The thing with the double slit experiment is there's so many different calculations you can do to give you the same answer. Once again, you can measure angles to get your answers. I'm just giving you a couple of formulas here. This is the second formula. So what you want to do is you want to highlight this. Don't click on it. I want you to copy and paste it. So put this into, okay, I think that worked. Let's wait and see. Here we go. Physics Classroom is a great source of information. And they have the double slit experiment. They have a simulation for it. So I go to the left-hand corner and I click on that and it will enlarge it. So this is how you get all of your different distances here. It says tap me right here. So you can play with the slit width and change it. You'll see that the bright fringes down here are changing. When I tap on that, you always measure from the middle of this 0 bright fringe out to the middle of 1, 2, 3, 4. So when you're doing your measurements, you have a scale right here, and you use that scale to do your measurements. You can also change the color of light that you have, red, green, blue, by tapping on this light source. Notice what's happening. Waves of light are coming here. We've got double diffraction, so we've got two slits. These slits have to be smaller than the wavelength of the light. We can change the screen distance. So we have the three measurements we need to do the calculation for wavelength. We've got slit width, it's got to be in meters. We've got screen distance, it has to be in meters. Then what you have to do is you have to use this scale here to get the distance in meters between the bright fringes. And what you should notice is that you are able to determine the wavelength of light using this.